Okay, the last section in this unit is going to talk about inverse trig functions. So first, I want to make sure we understand the difference between the word reciprocal versus the word inverse. Okay, so your cosecant, secant, cotangent, those were just reciprocals, using the same values in the ratio, just a different way. Remember, inverses undo what a function does. Okay, so for example, if sine of 30 is equal to 1/2, notice that in this function, the function is the sine function. Your input is an angle, and your output is the ratio of some sides, okay? Those side values. Remember, every time you want to change something into its inverse, then we're going to need a new function. Okay? And what that function is going to do is it's also going to have an input, and it's also going to have an output. The difference is that what's considered the input of this function and the output of this function, based on the fact that these are defined as inverses, they should switch. So over here, my input was an angle, then I expect the inverse function to have output values that are angles. So I don't expect to put an angle into an inverse function. I expect to put something else into an inverse function and for it to give me out an angle value. The output with our trig functions was the ratio of sides. That means I expect the input, the information I want to put into this function, to be the ratio of sides. Okay? So if we were going to use the same information, a 30-degree angle with a sine of 1/2, 30 would now be the output. The input would be the ratio of sides of 1/2, and that would be when 1/2 is put into whatever function we call the inverse function for sine. Okay, and that has a couple of ways that we can write it. Remember when we were learning inverses, if there was an f function, when we wrote this f with a -1 at top, we called that f inverse because it was the inverse of the f function. So this is the sine function over here. This is the inverse sine function. Okay, it can also be written like this. Arc sine. And we'll talk a little bit where they might have gotten that arc from in a minute, okay? So the -1 is the notation for inverse. The arc sine is another way of saying that. We're not going to use our calculator here, but you guys have actually used your calculator to do inverse functions before when we were solving triangles and you had to find an angle, so you had to get rid of the sine function, okay, or undo it, and that's what the inverse did. So when we do ask a question like this, okay, notice that I wrote this function and I said that this was its inverse. So let's look a little bit at the unit circle to understand the need for restriction. So I'm going to go back a few pages. I apologize. It's a little cumbersome for you guys. Look at that unit circle to give you some perspective. All right, so if I write this, like we were just talking about, okay, what I'm saying is, the way I would say it in words is the inverse sine of 1/2. So I would be asking you, what is the inverse sine of 1/2? What I would be thinking in my head is, oh, I'm supposed to find the angle where I already know that the sine turned out to be 1/2. And remember, you guys know that the sine is the y coordinate. So basically, instead of giving you an angle and you trying to figure out which coordinate they're talking about, they're telling you they already know the sine is 1/2. They already know the y coordinate on the unit circle would be equal to 1/2. They want to know what angle that happens at. So right here is an angle who has a y coordinate of 1/2. So one answer to this problem might be 30. However, right over here, there's another angle whose sine would also be 1/2, and that is 150. I could actually list infinitely many angles because there are infinitely many ways to name 30. I could keep adding 360 or subtracting 360 from 30, and I could get a whole list of new angles that all land at the same position as 30, coterminal angles with 30. I could do the same with 150. So if I take 150 and add 360 to it, I get 510. I could take 150 and subtract 360 from it and get negative 210. And I could again keep doing it, and I could get these infinite lists of angles. However, if you guys go on your calculator and you type this in, inverse sine of 1/2, it only gives you one answer. It just gives you 30. Okay, so this is where a person did step in and make some restrictions in the world of trig. If we're asking you for an inverse, we are always going to assume in our class, and you might learn some different notations later that differentiate this. In our course, we're always going to assume, unless it's asked for differently, that we're asking you for the principal angle. Okay, so I'm going to go back to our notes page. We don't want to get infinitely many solutions. We want to get the same solution that your calculator is getting. So in order to do that, they had to put some restrictions. And so it's going to be important for you to memorize these restrictions, or you might give the wrong answer. You might be giving me a coterminal angle instead of the actual answer that I'm looking for. So for our restrictions, if we're talking about inverse sine or inverse tangent, they're restricted the same. Okay. Think about your unit circle that we were just looking at. We want to restrict it to one answer. So for example, I don't want to let you give me an angle from quadrant 1 and quadrant 2 because there would be angles in those two quadrants that have the same sine value, and I only want you to give me one answer. So what they did for sine and tangent is they basically restricted it to this arc of the circle. So this comes back to the way that they might call it arc sine instead of inverse sine over here, okay? But we're going to take these both are going to mean the same thing to us. But we're only going to pick angles from this area, specifically only one time through that area. So specifically angles that go from negative 90 to 90. Or if you're talking in radians, that's negative pi over 2 to pi over 2. So what I'm saying here is if you are calculating inverse sine of an angle or inverse tangent of an angle, your answer, sorry, that would not be what you were calculating. If you're calculating inverse sine of some ratio, I'm trying to write a generic one, but it's a little hard for that, ratio, or inverse tangent of some ratio, you are getting an angle as an answer. That angle needs to be greater than or equal to negative 90, but less than or equal to positive 90. Okay. When we talk cosine, we don't want to use the same restrictions on cosine because there are angles in here that would have the same cosine because cosine is focused on the x values. So the restrictions on your cosine are a little bit different. If we think about the unit circle and we're trying to calculate an inverse cosine value, okay, or an arc cosine value, remember those are the same thing, we want to get used to that. We want to restrict it to a portion of our circle that would give us positive or negative x's, but not overlap. So in that case, they restrict it to this arc on the circle, and they specifically say to focus on angles from 0 to 180, or if you're using radians, that's from 0 to pi. So this means when you calculate inverse cosine, so you calculate the inverse cosine of a ratio, your answer is an angle. That angle that you list as your answer must be smaller than or equal to 180, but greater than or equal to 0. Or in radians, that's from 0 to pi, whereas your sine is from negative pi over 2 to positive pi over 2. Okay? And I'll help you a little more with what that looks like in a problem as we get there. This means that you are like the calculator. You're going to give out that one principal answer, not an entire list of answers like we saw when I was looking at the unit circle. Okay, so first we're just going to practice rewriting. So if we look at example 1, we're going to write each equation with its inverse, okay? So when I look at this equation, it says sine of something equals something else. The y is the input to the sine, so it must be an angle, and the x is going to be the ratio of sides. So if I write inverse for this, I would put sine inverse, and I'm going to switch the inputs and the outputs. Or I could have used arc sine, and again, I'm switching the inputs and the outputs. And remember, these are just two different ways to write sine inverse. Okay, with some numbers here where you actually see a 30-degree angle in 1/2 like we were talking about previously, this means we would say the inverse sine of 1/2 is equal to 30 degrees, or we could say arc sine of 1/2 is equal to 30 degrees. Okay. Here you see tan x equals -4/3. Again, remember, this is a trig function. That means this x is an angle and is the input. This is a ratio and is the output. As I write an inverse tangent function, I want to switch the inputs and the outputs, okay? Or I could write it as arctan of -4/3 equals x. Okay. All right, so that's just rewriting them in that format. Now we're going to go ahead and we're going to do some calculations with them, and then some more complicated calculations. So we're going to focus right here, right now. All right, so the first example 2 part A here says cosine of x equals 1/2. If we were to solve this, we basically want to take the inverse cosine of both sides of the equation. Then the equation would say x equals, and you guys have done this exact thing with triangles before, and then you've usually gone and typed it into your calculator. The difference is now we want you to be familiar with these special values and know them. So when I'm thinking, all right, x is equal to inverse cosine of 1/2, I'm thinking about the unit circle, and I'm thinking about the restrictions. The restrictions on this inverse function want me to focus on this arc, okay? Specifically angle values from 0 to 180. So I'm looking for an angle that would land its terminal side somewhere on that arc that would have a cosine equal to +1/2. So that's an x value of +1/2. So that would be right here at a 60-degree position. So 60 degrees is the answer to the problem, and I know that because I have memorized those different values of my unit circle. So I know that x is equal to 60 degrees. I specifically have to use 60. I cannot use 300 degrees, even though it also has a cosine of x, because of the restrictions we talked about earlier. We are specifically picking the angle between 0 and 180. So the only answer that's completely valid here is 60 degrees if you're using degrees, or pi/3 if you choose to write that in radians. So I'm going to look at the next problem. It already has it written in an inverse function form, so I'm trying to calculate this. You might not recognize this value, 1/rad2, but if you rationalize it, you'll see that 1/rad2 is the same thing as rad2/2. So I'm thinking about an angle that has a sine of rad2/2. That's how I'm calculating inverses. When they say inverse sine of rad2/2, they're telling me they know that the sine is equal to rad2/2, and they're asking me to find the angle. So sine is restricted from -90 to 90. So I really want to focus on finding an angle within those restrictions, not a coterminal one, but an angle that specifically meets those parameters. So when I think about this arc and the distance from -90 to 90, where I would see a sine, first of all, it's positive, so I know I'd be in the first quadrant, and I recognize rad2/2 as a coordinate that I see at a 45-degree angle. So I'm specifically looking for that y coordinate of rad2/2. So that happens at 45 degrees. So in this instance, my answer is 45 degrees. I cannot write -315 degrees. I cannot pick 135 degrees, even though it also has a sine value of rad2/2, because it's not meeting the requirements of the restriction. The only other way I could list this is using other units, which would be in radians, and to list it as pi/4. Okay. The last problem I see here says arctan of 0. If the arctan part bothers you, remember this is the same thing as saying inverse tan of 0. And this is talking about inverse tan, which has the same restrictions as the sine value. So as I look for my answer or think about that circle, I'm really going to focus on this arc and specifically values that go from -90 to +90. And I'm looking for something that has a tangent of 0. Now remember, tangent was the y divided by the x. If I know that that division resulted in an answer of 0, I know that the numerator had to be a 0 while the denominator is a number. So I'm looking for an angle that has a y value of 0, and then the x could be anything. So in this arc, the only position that that would work is here, where we have 1, 0. And so you could call that 0, you could call it 360 if you were just identifying the position. But in the case of the inverse, remember, you're specifically looking for the angle that falls at that spot, but is between -90 and 90. So that would either be 0 degrees or 0 radians. If you listed 360, you would technically be wrong, given the restrictions that we've spoken about. Okay. So then we're going to go down here and look at some more difficult ones. These problems have a combination of information, and we'll go through all 4 of these because they can get a little bit trickier. So when you look at them, you really want to process what's happening. You want to start just like you would with order of operations, kind of the innermost parentheses to see what you're calculating first. So here's the first problem I would focus on in example 3a, would be the inverse sine of 3 over 13. Now that's an inverse sine of something, so I know the answer to that should be an angle. And then once I find out that angle, I want to calculate the tangent of that angle. Okay. So now I want to focus on, can I find out that angle? So look at what the sine value is. See how it's the number 3 over 13? Look back at the examples that we just did previously. Here's an inverse sine problem. I was able to quickly solve it because I knew that the sine of the angle was rad 2 over 2. I don't know of any special angles whose sine value ends up being 3 over 13. That's not a familiar value to me on the unit circle. But if you remember a couple of lessons back, we said, when we're given information that doesn't seem familiar to those special angles, we can still figure out some stuff about it through a drawing and see if we can go from there. So though I don't know the exact angle off the top of my head, I'm going to do a drawing. And it still is an inverse sine problem, so I still want to focus on angles in these 2 quadrants. Okay, named, if I did name them, from -90 to 90. That means this angle, even though I don't know what it is, this theta, would have to be some angle in the first quadrant because the sine is positive. And if I'm only looking at this yellow arc that I've drawn, that's the only way that I would have a positive sine value. So it is some triangle here, and if I connect it back to the x-axis, it would look like this. Where sine is 3 over 13, that means I know that the y over the r is 3 over 13. Okay, and there's the angle. I cannot figure out the angle without a calculator. But the answer to this problem is not the angle. Okay, it wasn't just asking me for this part right here. It has this tangent in front of it, which means I don't necessarily need to know the exact value of the angle as long as I can go find the tangent of the angle. So I'm going to go look back at my picture of the angle and ask myself, can I find the tangent? The tangent should be the y divided by the x. Can I get that information? So I do have a y value there of 3. I'm missing the x value, but I could do Pythagorean theorem to figure that out. So I could do 3 squared plus b squared equals 13 squared. So that's 9 plus b squared equals 169. So b squared equals 160. And if I square root that, let's see, b would be equal to, this is 16 times 10, like 4 rad 10. So this will be 4 rad 10. Positive because both the x and the y are in a positive direction. So my tangent is 3 over 4 rad 10. Even though that's an odd value because it's not a special angle, so it's not something we're used to. And I will rationalize this denominator. And so then I'll end up with an answer of 3 rad 10 over 40. Okay. All right, I'm going to go through part B. So in part B, it's asking us to find the cosine of the inverse cosine of rad 2 over 2. And depending on how much you've understood of the notes, you might know the answer to this immediately. But for those of you that don't, let's look at it. So again, first part that we're thinking about is right here. So inverse cosine of rad 2 over 2. So I first want to remember that inverse cosine is restricted, and I'm looking for an angle that's between 0 and 180. The cosine is positive because this is a positive rad 2 over 2 in here, so I'm expecting this to be in quadrant 1. And rad 2 over 2 is a value I recognize from my unit circle. So I specifically recognize that as the x-coordinate when I'm at a 45-degree angle. So this is 45 degrees. And that's the answer to just this inner portion, the inverse cosine of rad 2 over 2. But then I'm going to find the cosine of 45 degrees. So I'm going to go ahead and go back to that 45-degree location and find the cosine, which is rad 2 over 2. Now, I said at the beginning of this example that some of you might recognize the answer already, and that's because cosine and inverse cosine basically undo each other. So see how I found the answer to the first part and it was a 45-degree angle, but then the cosine at that 45-degree angle took me back to that ratio of sides of rad 2 over 2. If you do see that right away, it's fine for you guys to recognize that and write it down. But if you don't, just work through the problem like normal and you'll be able to figure it out. Because these are a little bit more unfamiliar, I'm going to go through to try these as well. So I'm going to look at this first one. Focus on the inside. Arc cos of 1/2. That means an inverse cosine of 1/2. That means using my cosine restriction that goes from 0 to 180, I'm trying to identify an angle in that arc that has a cosine of 1/2. Since I know my unit circle, I know there's an angle right here in quadrant 1 whose x-coordinate is 1/2, and that is specifically at the 60-degree angle location. So arc cos 1/2, the inverse cosine of 1/2 is 60 degrees. And now I want to find the sine at 60 degrees. So this means go to 60 degrees, which I already have marked since I was there, and find the sine, which is associated with the y-coordinate. The y-coordinate at that position would be rad 3 over 2. All right, last one. Okay. Cosine of pi over 3. Now remember, pi over 3 is an angle. This is not an inverse function. They're asking for the cosine of this angle location. Don't get confused just because they give you something in radians. A lot of students will just list a degree here and think they're done. You're not. They are giving you an angle, and you are to find the cosine of that angle, which is a ratio of sides. So I'm going to think about my unit circle and where pi over 3 is. So pi over 3 is the same as 60. So it's right here at this location where the coordinates are 1/2 rad 3 over 2. The cosine is the x-coordinate. So the cosine is 1/2. So this is just like a question you would have been asked on like your Skill 5 homework where we practiced sines, cosines, tangents with radian angles. So this is 1/2. But there's a second part to this question, and that is now to find the inverse sine of 1/2. So now I'm going to think again about a circle, about the restrictions for inverse sine. So inverse sine, remember, is restricted from -90 to 90. So I'm specifically looking for an angle that falls from -90 to 90 who has a sine of 1/2. So given what I know about unit circle, I know there's a position here at 30 where the y-coordinate is 1/2. That's at 30 degrees. So the answer here would be 30 degrees. And then before I let you guys go try some of these for the homework, I do want to make one comment about a negative angle since that didn't come up a lot in our examples. Let's say that I asked you guys the inverse sine of negative rad 3 over 2. So your answer to this should be an angle. The inverse sine is restricted from -90 to 90. And so you're asking yourself which angle from -90 to 90 has a y-coordinate of negative rad 3 over 2. So the y-coordinate's negative. That's going to happen down here in quadrant 4. It's this angle that's 60 degrees away from x that would have that negative rad 3 over 2 in the y-coordinate. So here's a common mistake, is that a lot of people will list that as 300 degrees because it's 60 degrees away from 360. But remember, 300 degrees doesn't fall between negative 90 and 90. The appropriate name for this angle when you're solving this inverse problem is to call it negative 60 degrees or negative pi over 3. Okay, so a small reminder about that so that people don't get hung up on it. So you're going to do some practice with this. If you get stuck, remember to post your questions, and we'll have some tutoring sessions this week to make sure you guys can get all of this cleared up before we test.